Welcome to qnawire.
Let's start with the equation. Force due to pressure is going to equal delta P A, which is going to be equal to the resistive force of the spring when in equilibrium, which is KH. So we can express delta P as KH over A. We also know delta P is equal to P2 minus P1. So we can express P2 as P1 plus KH over A. Now we also know that our change of volume is equal to AH, and we also know that that must be equal to V2 minus V1, so we can express V2 as V1 plus AH. Now we can look at a modified version of the ideal gas law. P1 V1 over T1 is equal to P2 V2 over T2. We can plug in some numbers here, not some numbers, some equal equations. So P1 V1 over T1 is equal to P1 plus KH over A times V1 plus AH over T2. You will eventually distribute things, move things around, and find that KH squared plus H times P1A plus KV1 over A plus P1V1 1 minus T2 over T1 is equal to 0. And we like this because this is in a quadratic form we can work with. So when you plug in your numbers, you should arrive at an expression equal to about 2000 h squared plus 2010 h minus 396 is equal to 0. You can solve this with Wolfram Alpha online. I did it with my graphing calculator. You have 1y equal to 0, 1y equal to 2000 h squared plus 2010 h minus 396. And you can solve for the positive h, which is equal to 0.17 meters. You can also throw that in the quadratic formula, but that would be very messy. Now, B asks us to find that pressure, P2. Well, we can return to one of our original equations. P2 is equal to P1 plus KH over A, and just plug in our numbers. So P1, 1.01 times 10 to the 5, that's atmospheric pressure, or that's pascals, but that's standard atmospheric pressure, plus K, which is just 2000, H we just found 0.17, over A, 0.01 meters cubed, and you should arrive at a P2 equal to 1.35 times 10 to the 5 pascals. I'd also like to note that make sure when you do solve part A that you're using a volume unit of meters cubed. So you want to convert liters to meters cubed, temperature unit of Kelvin, and so on, and a pressure unit of pascals. Standard SI.